We are going to pick up right where we left off in section 5.7. This is part 2. We're writing linear equations using a point and a slope. So they're going to give us the point, they're going to give us the slope, and we've got to come up with the equation. We are going to deal with a couple interesting situations today though, so kind of keep your eye out for this. So just like before, the instructions are write the slope-intercept form of the equation with the line that passes through the given point and has the given slope. So here's the point and here's the slope. So just like we did yesterday, this is a huge chunk of information right here. So I'm going to write down y equals -3/2 x plus b. We don't know what the y-intercept is yet. I'm going to recognize that this is an x and this is a y, so let's go ahead and plug those in. So wherever there's a y, we're going to put a 1. Then we've got the -3/2. Wherever there's an x, we're going to put a negative, whoops, thinking ahead here, we're going to put a -4 plus b. So now I've plugged these into the values here. So I've plugged the y in right here, I've plugged the x in right here, and now we're going to finish solving this. So this is going to be 1 equals, notice that the 2 will cancel with the 4, so we're going to be left with a -2. So this is going to be -3 times -2, that's a +6, plus b, and then we're going to subtract 6, so we get -5 equals b. So we'll circle this, and remember that's the last piece of information we needed to get to write the equation correctly. So now we're going to go ahead and fill this in, and we're going to say y is equal to -3/2 x, and we know the y-intercept is -5, so we're going to go ahead and circle that. That's the equation that comes from that information that passes through this point and has that particular slope right there. So let's go ahead and graph this. This is going to be -5, and then the slope is -3/2. So we're going to go down 3 and right 2. And going the other way, we're going to go up 3 and back 2, up 3 and back 2, up 3 and back 2. So it looks something like this. So again, not perfect when we do these graphs like this, but looks pretty good. I've got a couple little waves in mind, but that's not too bad. Now let's go ahead and do our double check here. Let's make sure that this particular point, -4, 1, is actually on the graph. So if we started at the origin and we went left 4 and then up 1, left 4 and up 1, that's going to put us right there. Okay, so it is on there, so we're in good shape. We got that one right. Let's do the next one here. So again, we've got y equals, this is going to be 4/5 x plus b. I think I forgot to put the dotted line on that last one. Again, we're almost done. Again, if you couldn't finish this on a test, at least write down slope-intercept form with the slope plugged in. At least get that right. And then we're going to take this y and we're going to plug it in right here, and we're going to take this x and we're going to plug it in right here. So we're going to get -9 equals 4/5 times -10 for the x, and then plus b. I'm going to put that over 1, and we're going to do a little bit of cross cancellation here. That goes in there once, 5 goes in there twice. So this is a -9 equals, this is 4 times -2, so that's -8, plus b. We're going to add 8. This one's looking kind of familiar. So we've got a -1 equals b. So I'll put a dotted circle around that, and that is the last piece of information we need. We're now going to plug that in. So here's what we think the answer is. We think the answer is y equals, the slope is 4/5. Notice we could have written that down to begin with, and then we did all this stuff to figure out what the y-intercept was. It's -1, so we're going to go ahead and circle that, and then we'll graph this. So this crosses the y-axis at -1. And the slope is 4/5, so that means we're going to rise 4 and we're going to run 5. So run 5, that would put us right here. 1, 2, 3, 4 for a rise, 1, 2, 3, 4, 5 for a run. Up 4, run 5, that looks pretty good. We're now going to go down 4 and back 5, down 4 and back 5. Let's see, 1, 2, 3, 4, yep. Good shape there, everything lines up. We'll draw as nice a line as we possibly can, put arrows on it. We're all set, but we do want to do this little double check. We want to make sure that -10, -9 is on that line. So -10 for the x would be back here at -10, and negative 9 would go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Puts us right on there, so we are all set to go. These are very typical, these two problems, of the type of things that you're going to see on the assignments and on the tests that we take at the end of the unit. So make sure you can do those really well. Now it's time to take a look at something like this. And this is something that you've got to think about when we put all of this stuff together. It's not like we can just say, okay, here's how you do every single problem, because there are occasionally exceptions to the rule. So let's take a look at this, and you'll see why we've been talking about horizontal and vertical lines for the last little while. This says the slope is undefined. Now, if the slope is undefined, that's the same thing as saying there's no slope. Or in other words, if we were on a mountain slope, there's nothing for us to land on. There's no number that represents how steep that is. So then we've got to think back. Well, if there is no slope, if the slope is undefined, that means it's a vertical line. And if it's a vertical line, think back, that means it's x equals a number. Okay? If it's a vertical line, it's going to be x equals a number. Okay? So let's take this point right here. We know it goes through 3, negative 2. So over 3 and down 2. We know it goes through that point right there. Well, remember, all we need to know is what the x-coordinate is. Okay, the x-coordinate is going to be the same for all of these. So let's go ahead and graph this and notice where it crosses the x-axis. It crosses the x-axis at 3. In fact, we could just say, you know, I know it's going to be x equals a number. Well, which of these two numbers would it possibly be equal to? Would it be equal to the 3 or the negative 2? Well, it's not going to be the negative 2 because that's the y. So it's going to be the x coordinate, which is 3. And that right there is it. Done. End of story. The cool thing about that is there's no slope to find. There's no y-intercept to find or anything like that. We're just using what we know about horizontal and vertical lines to figure that out. Now, we're going to do the same thing on this one. If the slope is 0, that means it's flat. Okay? That means m is 0. That means it's a horizontal line. And if you remember, if it's a horizontal line, then it's going to be y equals a number. Okay? Now, I'm going to do this one backwards. We're going to graph it last. We'll definitely graph this one last. It does say we do have to graph it. So, if it's going to be y equals a number, which of these two numbers do you think it should be? Do you think it should be the negative 4, which is in the x position, or the 6, which is in the y position? It's definitely going to be the 6, so let's put that there. Let's circle this, and then let's confirm our answer by double checking this. So, let's see here. This would be negative 4, 6, so back 4 and up 6, so right there. And then if it has a slope of 0, it's perfectly flat, so it goes like this. It's horizontal, okay? Is that the line y equals 6? It is, because look where it crosses the y-axis. It crosses the y-axis at 6. It's parallel to the x-axis. It doesn't have an x-intercept. It doesn't cross the x-axis. And we're all set to go. Okay, those are the type of problems that you're going to see today. Okay, so make sure you can do those, whether you're given a point and a slope and then you find the y-intercept and all that sort of stuff and come up with a regular old slope-intercept equation, or you've got one of these exceptions where we've got no slope or the slope is undefined, we've got a vertical line so it's x equals a number, or it's got a slope of 0 so we've got a horizontal line so it's y equals a number. Now, if you're interested, there is another way to make this just a little bit easier if you like this. I'm going to do one example. It's not included in the 8th grade curriculum, but I thought I'd show you really quickly if you're interested. If you're not, you don't have to watch this. This isn't required, but it might be a point of interest. So here's what we're going to do. This is called point-slope form of the equation of a line, and it's y minus y1 equals mx minus x1. Whoops, x minus x1. Okay, and it comes from the formula for the equation, or the formula for the slope of a line. So I'm going to write it like this. Now you'll notice what I did here is I didn't put the y2 and the x2 on here. I'm just saying this is kind of a generic y, and if I were to multiply both sides of this equation by x minus x1, those would cancel and I get this format right here. Now if you don't follow that, that's fine, but it does come from the slope formula. So here's what we're going to do. This is our xy pair, so we're going to call this x1, y1, and this is our slope. Okay, so what we're going to do is we're just going to plug all of these pieces in. So we have y minus y1 is 1. The slope is negative 3/2. and then this is x minus x1 is negative 4. So the minus is part of the formula, and then the negative was part of the number that we plugged in. Okay, so this is going to turn into a plus. So this is going to be y minus 1. This is negative 3 halves. And then we're going to distribute through here, so this is what we're going to get. So we're going to have negative 3 halves x. And then I've got negative 3 halves times 4. So this is going to cancel, and that's going to be a 2. So I get y minus 1, negative 3 halves x. This is minus 6. And then the only thing I need to do is just add 1 to get that y by itself. I'm getting this in slope-intercept form. So this is y equals negative 3 halves x, and then minus 5 right there. So that's the answer. Now I'm going to grab this and I'm going to show you where this came from. So think of y equals negative 3 halves x minus 5. That is the same information. Take a look at what we've got right here as that one right there. That is example A. I did that 2 different ways. So I'm going to shrink this down and show you. This is the work that it takes to do it by writing it in slope-intercept form and then plugging in the numbers. We get that answer. This is plugging it into slope-intercept form. Now, to my eye, it looks kind of like it's about the same, except for this is kind of a 2-step process. This is kind of like one. We plug this stuff in and then we solve it. So kind of a cool technique. Just keep in mind that there's something called point slope form. If you're interested, you're welcome in trying some of those out like that using point slope form. But if you'd like, just do them all this way. That's what most people end up doing. But just be aware you might see something like that in the future. Okay, good luck on that assignment.